Okay, so this is another test we're gonna be doing. We're gonna be working with this this is the Miniklausur from 2022. So yeah, it's pretty easy. Let's first start with 77. Well, this thing, they're telling us to convert a decimal number into hexadecimal and BCD. So a trick I do is always write my little table here, right? To like start converting numbers quickly. And then I say, okay, what number gives me 77? So in this case, 77 is a big number. So we have to add more, how you call this, value. So let's do 1, 2, 4, 8, 16, 32, 64. I think that should be enough. So what can we add? What do we have to add to get 77? So we have 64 plus, let's say, plus 6, right? It's going to be 70. But then we want still 7. So 7, we know that's going to be like something like that. That's 7. Now we want to just add up 70. So how do we do this? We can also do this, for example. We can do, this one is going to give us 72, right? And then we do 5. This is going to give us 77, right? Perfect. 77. Now, we know that the hexadecimals are up until 8. So we want to basically divide our number in 2 sections of 4 digit, the bits. So we do this. This will include a 0 over here, obviously. So what we do now, simply put, is if we put a little division here. We put a little division, right? And we're gonna add it just like that. We're gonna take this, and we're gonna take this. So this guy, we'll put it here, is gonna give us, simply put, this is gonna give us, oh, this is decimal, this is gonna give us 4, and this is gonna give us, well, think about it, 1, 4, 5, this is gonna be 13. Now we know that whenever we have A, B, C, D, E, and F, in hexadecimal, this is equal to 10, 11, 12, 13, 14, 15. So in this case, we have 13, which is going to be equal to D. So at the end, our value in hexadecimal, we can say that 77 decimal is equal to 4D hexadecimal. And the BCD is quite really simple. We just need 7 and 7. So to make 7, we do 1, 2, 3. This is going to be equal to 7. So simply put, 77 in decimal is going to be 0, 1, 1, 1, 0, 1, 1, 1, and there's going to be BCD. That's it. So our 2 solutions that we require here, this little guy and this little guy, right? They're asking us to now create, change the decimal numbers to 14, 7. So again, we make a little 8. This is enough for our 2 values. So 7 is going to be this. This is going to be 7. And then we want 14, which is going to be everything except 1. So this is going to be 14. So we want to add these numbers, right? So 0, 1, 1, 1, 1, 1, 1, 0. It's easy. This is going to give us, right? If you want to check it out and verify that this is an actual correct value, right? This is going to be 16. How much is 7 plus 14? Is going to be 21. So we add this 1, 4, 16 is going to be 21. So this is correct. Just add a plus here. So the actual solution is this guy. Let's continue. We want to create this subtraction. We already did this in our Blatt 2. So 1, 1, 0, 1, 0, 0. We want to convert to first complement, then second complement. 0, 1, 0. So now we add 0, 1, 0, 0, 1, 0, 1. And we take these and we make them bigger. Oh, that's a bit too big. Oh, whatever, I'll just rewrite it. 1, 0, 1, 0, 1, 0. 1, 1, 1, 1, 1, 0, 0, 1, 1, 0. That's our value. Now, obviously, just by looking at these values, we're gonna see. I'm gonna remove this. Just look at these values. This one has a bigger number, has a most significant bit is bigger than the most significant bit of this one. Therefore, the subtraction will be positive, right? So this will be positive. In this case, we can cancel this out. We can cancel this out because it's going out of the bounds of our subtraction. So we have our value this. So this is going to be 15. And we know it's positive because of that. So this is going to be 15. So that's decimal system. Right. Now we're done with this one. Pretty easy. Now this one they're telling us this is an XOR. We want you to create a Wahrheitstabelle and show that this is XOR. So it's really easy. You just take A, B, and then we just create a table here. Not A and B. Another one here. A and B. A and B. A and B, or A and B. In this case, we're going to put this and that. And this we're going to do A XOR B. So we do 0, 0, 0, 1, 0, oh, 1, 0, 1, 1, then 1, 1, 1, 0, 0, 1, 0, 0. So A and B, A and not B, A and not B, oops, A and not B is going to be 0. A is going to be 0, this is going to be 1, this is going to be 0. Again, A, not A and B, so 0, this is going to be 1, this is going to be 0, and this is going to be 1. Now this OR, so 0, 1, 1, and this would be, no, this won't be 0. I did a mistake here. Not B, and this guy is going to be 0 here as well. So this will be 0, 0. And this one is equal as XOR. This one is sort of equal. So we can continue. They're telling us that we have to take this and, you know, you have to minimize it through Boolean algebra. So let's focus on, first of all, this little guy. So basically, they're asking us, what is this? So let's try this out. This one is simply going to be not A, right? And not B, or A and B, simply put, if I remember properly. Let me just check it real quick. There's already solved this, but I'm just reviewing it for my study session. That's whatever. Where is it, man? Yeah, here it is. Yeah, that should be correct. Now, we know for a fact that we're going to have also not C and not D, right? That's for the first one. And then we have this guy, which we have to use with consensus. So consensus tells us that whenever we have A and B plus not A and C plus B times C is going to be equal to, simply put, these little two guys. So in this case, let's just take this guy, right? And let's verify that this is true. I'm gonna copy it because I don't want to write it again. I'm too lazy. In this case, we can see that E and not E is gonna be A and not A, right? Then we have times times, and then F is gonna be our B, and then G is gonna be our C. And as you can see, we have B and C, which is gonna be equal to, of course, E, which is gonna be not A, and B, so F plus E not, and then G. So that's gonna be it. That's simply put it. So we can put it all together, right? So we take this little guy. Well, this was just it. We take this little guy here. We duplicate it. Remove everything like that. And then we're gonna have an and. So it's an and in this case it's gonna be this. Right. I'm gonna rewrite it with the dumb operators, correct operators. This and, oops. This is and, this is or, this is and. Right. And this is gonna be or H. And that's pretty much it. That's pretty much how it is done. We cannot further develop this. We could theoretically just continue it on, but we can just leave it like that, because distributing this will not lead to anything. So we can just leave it like that, basically. Because we could multiply, theoretically, this guy with this guy and this guy, and then this guy with this guy and this guy, and then this guy with this guy and this guy. But it's not going to bring anything at the end of the day. It's going to be the same thing. So that's how far we can get off. Okay, now they're asking us this one. We have to do Schaltfunktion with this guy, only with freaking non-getter. So how do you remember that whenever you want to negate something, you have to take a NAND, and there's going to be a negative. Whenever you have to do a proper AND, right, you have to take, simply put, you have to take, well, simply put, if you want to do A and B, for example, there's going to be an AND, and then you have to negate it again by itself. So you get A and B. So that's another one. And the OR is a whole deal. It's I'm gonna just rewrite them here, okay? The ORs are basically A, you negate them themselves, oops, and then B, they negate themselves as well. And this one is going to be equal to another negation. And this is going to give you not A times B. And this is going to be, simply put, A or B. Okay, so that's pretty easy. Now let's begin. They're telling us that we have this, Non-Gettern, das Weihen besitzen, blah, blah, blah. Inverters sind verboten, müssen durch Non-Getter realisiert werden. So they can only use Non-Getter, which are these guys. So simply put, we begin with not A. Right, so it's pretty simple. Just begin with something like this. So in this case, we have not and then we have we want to simply put make our B and C, right? So let's do the B and C. We can actually do the B and C together first. So simply put, we just take these two guys, and as you remember, we have to negate them first. So let's negate them first. Oops. So we have not B and C, right? So this then goes into another negation, and this will do B and C, right? So now we want to do the same thing. So we do, okay. Right, this is gonna do not A times B and not and C, which is gonna be not. I'm just gonna move this to the top. And now we'll just move this along. Just move this along, you guys. And we want this to be by itself, so we have to negate it as well. And now we'll have not A times B times C, right? But remember that we wanted to have it negated, right? We want to have it negated. So we don't need this by itself, right? We really don't need this. What do we mean? Is we actually wanted to have this effect. So we erase this, right? And we can check this out. Why? Look, so we can take D and E, right? This is gonna be D and E and then cancel. So we can take these two again. Yeah, simply put, we can just leave it like that. And these are the negated versions of it. So if we just add them together into a non-gata, we cancel both out because we'll have A times B times C negated, so to speak. And then we have this guy, D and E negated, and we negate the whole thing. And as we know, this will cancel out. And this is going to be a plus. And then D and E. And that is pretty much what we wanted, huh? That's our solution, basically. That's it. So we can do this in partial. And we can just replace this over here. Over here. And as you can see, we are pretty much done. We're done with our exercise here. Oh, well, this is Y, basically. Just, yeah, this is basically it. Just like that. Okay. Codierung, let me just erase all of this. Okay, let's see. What do they want from us from here? They're asking us to do this. This is pretty easy. They're asking us, oh, you have to take the following symbols and you have to give them. We have to do basically the Hoffman thing. So we start by writing the smallest ones. So let's do that. Let's cancel out. G is 1, so we cancel out. Then the last is C equals 3. Cancel it out. H equals 4. Cancel it out. B equals 4 too. It doesn't matter. Then F equals 6. Right? Cancel out. A equals 9. Oops, that's a bit too much space, so we cancel this out. D is equal 10. So, simply put, we can just add these together. And if we add this together, we're going to have 2, right? 2, which we can add then with this together, right? So, we're going to have 5. So, and then we can have these 2, and it'll be 8. So what do we mean with that? So we're going to create this. In this sense, we have the smallest one is going to be 2 and then 3. Okay, so it's going to be E. I'm not going to write the numbers because it just makes it more time consuming. 2 and then G. This is a G, okay? Let me just rewrite it because it looks like it's 6. bro. Looks horrible. Then we have a C here, and it's gonna be 5. Right? C. And once we have 5, we get F, which is 6. So it's gonna be 11. It's gonna be 11. Well, I'll just leave it like that. And then we have C3. So we've done this, we've done this, we've done this. And then we have these two, which is gonna be 8. So we have F equals 6 here. And then we have 8, which is gonna have H and B. Oops. 8, which has H and B. H and B. And yeah, we have these two guys as well, still. And then we can just rewrite this. This is gonna be 11, so we're gonna have 11 and 8. So we can add them up. So it's gonna be 19. It's gonna be 11, and then 8. 8 has H and B. 11, what does 11 have? It's gonna have F. It's gonna have 2 EG. No, 5, sorry. I'm gonna have 5, which has C, which has 2, which has EG. E and G. We have 19. Therefore, oops, no. Made a mistake here. You don't want to go ahead and go crazy with this. That's the thing, though. You have to be careful with this type of stuff. Because once you have 11, right? 5 and 6. We have 11. Oops. We have 5 and 6. Oh, it's F, not 6. We cancel these out. 5, 6. And we have 11. And the next one is 8 and 9, right? So, in this case, let's see what we're doing. Let's see what we're doing. We have 5. This is gonna be 2. This is gonna be C. This is gonna be E and G. F is dead, so let me just rewrite this. So we have 8 now, right? Some dumb 8. And what do we do with the 8? That is the question. We have 8 and 11. So we still have 8 and 9 now, right? So we're gonna add these up. So it's gonna be 17. And this is gonna be 10. Well, AD is equal to 10 basically. So we can just have it there. 17, which is gonna be 9. Oops, A, sorry. A, and then 8. HB. Right? And then this will turn into, let me think, 17, okay, so 21. We're gonna have 21, 17, 17, and 21, right? This is gonna be basically 38. 38, oops. So, right. So 17 stays the same. A, 8, H and B. And then we have 21, which is going to be 10 and 11. So 10 goes to the left. 10 and 11. And 11 goes F5, yeah, all the same thing. F and 5, 5 to C, C, 2, and then EG. And so we are done, so to speak. So we can count our values. We have 0 and 1, 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 0 and 1. Now they're asking us to get A. So A in this case is going to be 0, 1. Quite simple. Then B is going to be 0, 0, 1. 0, 0, 1. Then C, where's C? 1, 1, 0, 1. 1, 1, 0, 1. Then D, where's D, you guys? What the hell did I do with D? Oh, D is, it's this one. I forgot. I wrote 10 instead of D. It's gonna be 0, 1. Then E is gonna be 1, 1, 0, 0, 0. 1, 1, 0, 0, 0. F is gonna be 1, 1, 1. 1, 1, 1. G is gonna be 1, 1, 0, 0, 1. 1, 1, 0, 0, 1. 1, 1, 0, 0, 1, yeah. And H is gonna be 0, 0, 0, so 3 zeros. Okay, cool. So as you can see, we have basically, yeah, we have this. What is this? What are we doing here? I'm just looking at the solution over here, and it's kind of weird looking. Whatever. So in this case, we have all of these values. Given C, aus dem Code in Tabelle an. And then they're asking us, wie viele Bits sind mindestens notwendig, wenn man für die Codierung jedes verwendeten Zeichens dieselbe Anzahl Bits verwenden würde. So in this case, we have 1, 2, 3, 4, 5, 6, 7, 8. 8 different numbers, right? So we have 8 different numbers. So what combination will give us, what of this is going to give us? Is going to give us 8. This can be calculated by LD of 8. So with LD of 8, logarithm of 8 is going to be 3. So we need 3 bits, so to speak. So 3 bits. Now, we have 3 bits, right? And we want to know how many values do we have here. So in this case, if we add all of these up, right? If we add all of these up, how many bits do we use? So we know that if we just use one of each, it's going to be 3 bits, 3 bits, 3 bits, right? Imagine instead of, let me just write with a black one maybe. There we go. If we have something like, let me just write a square. Man. There we go. Okay. I'll just give you an example here. Let's just do fill black. Okay. Imagine we just had 1, 1, 1, 1, 1, 1, 1, 1. If we had 1 and we used it only once each time, we would use 3 times 1, 2, 3, 4, 5, 6, 7, 8. So it would be 24 bits, only if we use one character. However, in this case, we have this amount of characters, right? We have a different amount of characters. We have a 9, 4, 3. So 3, right, is going to be 3 times 9 plus 3 times 4 plus 3 times 3 plus 3 times 10 plus 3 times 1 plus 3 times 6 plus 3 times 1 plus 3 times 4, right? In this case, it's a lot of 3s, as you can see. It's not that difficult, but it is a lot of 3s. So we can, so to speak, just 3, and then we can just multiply this by the sum of all of these values. So in this case, all of these, 9 plus 4 plus 3, is going to give us a total of 9 plus 4 plus 3 plus 10 plus 1 plus 6 plus 1 plus 4. It's going to give us 38, right? So we go back. 30, this, and 3 times 38 is equal, times 3, 114. So in this case, wie viele Bits sind mindestens notwendig, wenn man für die Kodierung jedes verwendeten Zeichens dieselbe Anzahl Bits verwendet würde? In this case, it's going to be 114 bits. And that's it. This is pretty much how you solve this Miniklausur. Hopefully you understood. The only one that I would say it's a bit tricky is this little guy, because we had to like not negate this one. We just had to see the structure of being like, oh, we don't need to negate it anymore because we already have it negated, and that's what we want, you know? Just take care of that, and I think the rest of it is quite easy. Oops.